A few words on what is called implicit differentiation in calculus. Now, the definition of a function is there can only be one y at any particular x. But there are, of course, many graphs, a lot of equations, where it doesn't act that way. For example, a circle. A circle is not a function, a proper function, because you have two places, at most instances, except on the end, so to speak. At most places, there's two y's for every x. It's a valid equation, but it's not a function in the normal definition of a function. And so we still often need to find what the tangents are to equations. So what is the tangent to a circle at a particular point? Well, it's hard to, actually with this one it's not, but with some equations it's sometimes difficult to rework, the equation into a y equals something format. And so the idea of implicit differentiation is that you're doing it you're doing it as the equation comes to you, rather than going ahead and trying to convert it into a y equals something kind of format. So here's how you do it. You differentiate the equation as it stands with regard to x, and the with regard to x is important. Then you follow the rules and use the tools. So, like the chain rule you might use at some point, or the rule for differentiating things that are multiplied, or the rules for differentiating things that are divided. And then you solve for y prime, or y prime is one way of writing dy dx, the derivative of x in relation to the derivative of y in relation to x. Y prime is another way of writing that. So here's an example. Take this equation. Now, I'm sure we could work on this to try to get it into a y equals something format. Use the quadratic formula, or something. Actually, we couldn't use the quadratic formula. But it's much easier to just differentiate it implicitly the way it is. So we're going to basically differentiate it as it stands. Now, the derivative of x squared is easy. It's 2x. The derivative of xy is going to require us to use the product rule for differentiating. The product rule is if you're going to differentiate something times something, you differentiate the first multiplied by the second, and then the second plus the second multiplied by the first. So the first times the derivative of the second is x times y prime, and then the second times the derivative of the first is y times the derivative of x, which is 1. So yx prime plus y, this is the derivative of this using the product rule. To differentiate this with regard to x is more difficult than a beginner might think. And that's because normally if you were differentiating y squared with regard to y, that would be one thing. But we're not differentiating with regard to y. We're differentiating with regard to x, and so we're going to have to use the chain rule. It's going to end up as 2y times y prime. But let's just remind ourselves of how the chain rule works. If you're using James Stewart's 6th edition calculus, the chain rule has been the section right before this. So if you want to find the derivative of y squared with regard to x, then you're going to use this the differentiation of y squared with regard to y and multiply that by dy dx. The reason you do that is because if you want to think of it this way, the dy's cancel out and you're left with dy dx. Remember, we're differentiating this in regard to x, and so that makes it more complicated with differentiating a y. So here's how this plays out. So the derivative of y squared with regard to y, well, that's easy. That's just 2y. And the derivative of y with regard to x, well, that's what we're trying to find. So that's y prime. And so if I use the chain rule down here, the derivative of this is going to be 2y times y prime. And then, of course, any constant, the derivative of any constant is 0. So there you have how I got the second line. So now we simply reduce this by combining like terms and solve for y prime, solve for the derivative. And so let's take the parentheses out. That's all pretty straightforward. Now we're going to group. Let's get the y primes on one side, on the left, and then everything else pull over to the right. And then we're going to pull the y prime out of the parentheses so that we can then divide by x minus 2y, and we're left with, initially we were left with negative 2x minus y over x minus 2y. But it's prettier. This is prettier answer, and so I just factored a negative 1 out of this, and then factored a negative 1 out of that, and then we can get rid of the negative 1s, and we have a nice little neat answer, which is of course the answer that Stewart gives in the back of the book. So there you have implicit differentiation.